I'm going to do 9.2 today. Try to go, I'll try to go as slow or as quick as we can and make things happen. We're going to talk about radicals, square roots, cube roots, things of that nature. I'm going to show you how to find the domain. I'm going to show you how to graph them. Things like that. It's actually not too bad. You guys probably already got all this stuff down anyway. If you want to look, there's our objectives right up there. But first of all, let's go ahead and take a look. So we have these two different functions here, f of x and g of x. So here when a says find f of 9, that means we're going to take 9, go to the f function, and plug 9 in for x wherever you see it. So that would be the same thing then as the square root of 9 plus 2. Square root of 9 is 3, so that's 3 plus 2, which is 5. So f of 9 equals 5. Okay? Now, look at the g. So this is a g function. So we can take g and we can take negative 3 and plug it in. It's going to give us the cube root of 3 times negative 3 plus 1. 3 times negative 3 is negative 9. So that's the cube root of negative 9 plus 1, which would be the same thing as the cube root of negative 8. As I look at the cube root of negative 8, well, that is negative 2 times negative 2, which is 4 times negative 2, which is negative 8. So the cube root of negative 8 is just negative 2. So g of negative 3 equals negative 2. That's kind of an interesting thing right there just to recognize, and we've talked about before. But again, just take a look. Can I take an odd root of a negative? And the answer is yes. It just comes out negative. But I cannot take the even root of a negative. Okay? It comes out imaginary. So, odd root with the negative is okay. Even root with the negative is not okay. Has to be positive. So now it says they want f of 9, which we know to be 5, plus g of negative 3, which we know to be negative 2, and that's going to equal 3. So this equals 3. Okay, done. Here we go. So again, this part right here is just talking basically exactly what we were just talking about. If it is a square root or a fourth root or a sixth root, the numbers that we want to put in for x all need to be greater than or equal to 0. So whatever is inside of this root, if it's an even root, meaning if this is a 2, we never write the 2, right? But it's there, or a 4 or a 6, if it's an even root, whatever is inside has got to be greater than or equal to 0. If it's an odd root, take a look here, an odd root, which is a cube root of x, or a fifth root of x, or a seventh root of x, then we talked about it up here, it could be negative, it could be positive. So in other words, here, anything can go in for x. All right, anything can go in for x. Up here, we have to restrict to make sure everything inside is bigger than or equal to 0, because I cannot take the square root of a negative and get out a real number. It comes out imaginary. We've done those before too. So here it says find the domain. So the domain are the values I can plug in for x. So remember, anything inside of that root, so in this case, x minus 5, has got to be bigger than or equal to 0. Add the 5 over, and we get x has to be bigger than or equal to 5. So we would say that our domain then is from 5 up to infinity, because that means, so the bracket on 5 can be equal to, and I'm going bigger than or equal to 5, so that's 5, 6, 7, 8, all the way up to infinity. Any of those numbers work. Now take a look here. It's an odd root. Well, if it's an odd root, remember, anything can go in it. So my domain then just goes from negative infinity to infinity, and we're good. All right, take a look here. It's an even root again. Okay, that means everything inside of here, 5 minus 2t, has got to be bigger than or equal to 0. Subtract the 5, gives us negative 2t, greater than or equal to negative 5. Divide by negative 2. Now, hopefully, you can remember from past years, and if not, I'll teach you right now. When you divide or multiply by a negative, if you divide or multiply by a negative, this sign here has to switch, has to flip. So instead of being greater than, it now flips to less than or equal to 5 over 2. That just is it's a rule that happens when you're dealing with inequalities. if you divide or multiply by a negative, you need to switch the sign, or flip this sign right here, okay? So that means my domain in this case then, would be less than or equal to 5 halves. So that's going to be down to negative infinity, up to 5 halves with a bracket. All right, take a look here. They want us to graph it. Well, if you're never quite sure what you want to do with the graph, just plot some points. So x, y. Remember, this is an even root. If it's an even root, then we need to restrict x. X has to be bigger than or equal to 0. So I would start at 0. I would pick 1. Now, do you know the square root of 2? It's like 1 point something. Square root of 3, 1 point something. But we do know the square root of 4. What's another one you know a square root of? I hope you said 9, because that's true. So the square root of 0 is 0. The square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So I get 0, 0, 1, 1, 4, 2, and then 9, 3. Okay. So that graph's looking like that. That graph looks like that. So my domain is from bracket 0 to infinity. The range, look at the range. Oh, it also starts at 0 and goes up to infinity. Okay. Let's go ahead and look at this guy right here. Hey, folks, do you remember me talking just a little while ago about IHOP and overs? Inside, it was usually inside parentheses, but I also said it could be inside a square root. Affects the graph horizontally. Opposite of what you think. Where is this minus 2? Is it inside or outside of the square root? It is inside of the square root. It's going to affect the graph horizontally, opposite. So I'm going to take this graph here and shift it to the right 2. So this point goes to the right 2. This point right here is going to go to the right 2. This point right here is going to go to the right 2. And so there's my graph. It looks just like this one, shifted to the right 2. Why to the right? Because that's opposite of minus 2. So the domain here is going to be from 2 to infinity. The range is from 0 still to infinity. Brackets on the 0 and the 2 because they do equal those. And then this down here, notice anything about the graph, they just want you to notice that it shifts. All right, let's do a couple more graphs. All right, let's look at the cube root of x. Now, if you remember the cube root of x, we can do anything. If it's an odd root, we can put anything in. So, I would recommend things like -1. Now, -2, I don't know the cube root of that. I don't know the cube root of -3 or 4 or 5 or 6. But I do know the cube root of -8. That's -2. Cube root of -1, that was -1. Cube root of 0 is going to be 0. Cube root of 1 is going to be 1. And then I'd come out to 8 again because then the cube root of 8 is 2. So pick values here that it's easy to take the cube root of. At least that's what I would try to do. So I get 0, 0, 1, 1, -1, -1. Then I'm clear out at 8 before I get up to 2. -8 down to -2. Okay, look at this big bad boy. Here he goes. Okay, so it looks kind of like a really squatty-bodied S. The domain is -infinity to infinity, and the range is also -infinity to infinity. So right here, based on that information, look at the cube root of x. We already know the domain, -infinity to infinity, could be anything. And the range is also going to be -infinity to infinity on these, okay? Always. So now let's go ahead and take a look at graphing this thing. Well, where is this +2 located here? Is it inside of the cube root or is it outside? I hope you said outside of our radical. That means it's going to affect it vertically, the same as what you think. So it's going to be this same graph, just shifted +2, which means shifted up 2. So this point that was here is going to go up 2. The point that was a 1, 1 is going up 2. The point that was a -1, -1 is going up 2. The point that was at 8, 2 is going up 2. So that's at 8, 4. Point that was at -8, -2 is going up 2, so -8, 0. And take a look at my graph there. Oh my gosh, it looks just like that one. Shifted up 2. Woo woo! There it is. That's what they wanted you to notice. All right, let's take a look down here at 7. Last 7 and 8. Last two things we got going on. So first of all, it is an even root, which means our domain is restricted. Because we know that x minus 3 has got to be bigger than or equal to 0. Add the 3 to both sides, so it gives us x got to be bigger than or equal to 3. So my domain right now is going to be from 3 to infinity. Okay? The range, I need to graph it to see what that range is going to look like. Now let's take a look. We know what the square, if it was just the square root of x, if it was just square root of x, we would have the points at 0, 0, 1, 1, 4, 2, 9, 3. Those would have been my points, right? Right there. That would have been my graph right there if it would have been just the square root of x. But look what we got. First of all, we have a inside, that's a horizontal shift, opposite of minus 3. So this point's going to go to the right 3, 1, 2, 3. Right 3, 1, 2, 3. To the right 3, 1, 2, 3. So now, oh my gosh, looks just like that one, but shifted to the right 3. Now look, we have a -2 on the outside. Outside vertical same. So I'm going to take, remember, vertical are your y values. So I'm going to multiply those y values by -2. What's 0 times -2? 0. What's 1 times -2? -2. What's 2 times -2? -4. Okay, so here's that graph now, and it's looking more like that. So it looks a lot like this, but just a little bit vertically stretched and reflected. Does everybody see that? So this is my final answer right here. That one right there. Let's see if I can make it a little bit more distinguishable to you. Okay? It's going to be this one right here. This is the final answer right there. This was the shift to the right because of the -3. Then these y values, this one at 0, got times by -2. 1 times by -2. 2 times -2. You can see that it reflects it and it vertically stretches it a bit. Okay, so my range, so if I look at the range, ooh, it goes down to -infinity, up to 0. So if the range is -infinity, up to 0. Always put your smallest values that it'll go to first. Okay? All right, let's take a look at 8. Take a look at 8. The cube root of x plus 1 minus 2. So if it was just the cube root of x, we know the domain, -infinity to infinity, so there's no restrictions. And the range is also -infinity to infinity. Now the thing that we need to check, is we need to check the graph here. Cube root of x is at 0, 0, 1, 1, 8, 2, -1, -1, -8, -2. That is our normal cube root of x. Remember, it looks kind of like that big squatty body S right there. We have an inside plus 1, which means inside, horizontal, opposite, IHOP. So horizontally, left to right, I'm going to shift it to the left 1. This point gets shifted to the left 1. This point 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 shifted to the left 1. They don't mean to be on the same, but they kind of look like they are. Anyway, we can see that it is actually, looks very, very similar to this one right here. Just shifted to the left 1. Then the -2 means I'm going to take these points and shift them down 2. 1, 2. Shift them down 2. 1, 2, because it's outside. Vertical same. Shift it down 2. 1, 2. Shift this point down 2. 1, 2. Shift this point down 2. 1, 2. So there it is. So again, I'll try to make that a little darker for you. Here's my final answer. Looks like that. And folks, that's all 9.2 is about. So hope you had a great one. And let me know if you have questions. We'll talk to you later. Hopefully we'll see you later today. I'm going to do that conference call, and hopefully we can see you. So we'll see you later. Have a good one. Bye.